Alright guys, welcome back. So what you don't realize, you'll ever spend an hour on something and then screw it up and realize you didn't do it right. So this is like the second time I'm doing this video, part of the lecture, because yeah, I lost it. Yeah, let's do it again. Alright, Ernest Hackle. So I'm going to preface this real fast and say that I don't like him. For reasons we'll talk about. And I'm going to try to be biased and nice and not be a smart aleck and a jerk about this man. And if I do, I apologize. It's unprofessional about me. And so we'll see how I do. Y'all can tell me if I was nice to this guy or not. Alright, so Ernest Hackle. Why is he important? Alright, embryology. Taught that each animal retraces its stages of evolutionary development in its embryo. So, what that means is, we'll go to the next slide. So what that means is that we see this column right here. This is the fish, right? And so this is the 4 weeks mark. A few weeks later, but the key thing right here is the 4 weeks mark. So we can see. So this is a fish, salamander, turtle, chicken, pig, lamb, dog, and human. Okay. So you see all these. This is the big one right here. If you see all these little folds and layers, right? You see it all the way back to the fish, okay? This was his claim, okay? That as the fetus or the embryo goes through and develops, it retraces all its developments, and it actually, those folds are gills. Like it has gills, like you guys had gills one time when you were a fetus, okay? So let's talk about it. Here's an actual image. All right, a dog and a human. You can see those. There are the folds. There are the folds. You can kind of see the belly right here. He's got a big old belly. Let's talk about it. So we see through these images that the dog's head, okay, it was increased in size proportional to the body. The human head was decreased. The eyes were changed. The length of the tailbone was changed. And yes, you do have a tailbone. Okay, it goes past your hips. You don't have a tail, right? The arrangement of stuff. There's other things that were wrong here. And realize your tailbone is really important. There's important muscles that attach to your tailbone. An anchor there is points. There's also important nerves. Fellas, if you ever break your tailbone at the right spot, you'll be unhappy for the rest of your life, fellas. There's something you want to do that you will not be able to do. It just won't be any fun for you. So here's some actual images. And we don't have the dog, but we have the rabbit and other organisms. So if you were going to grade this guy, would he pass or fail? So let's talk about it. Especially, not only grade his drawings, but let's grade his claim. Okay, drawings, but his claim is something different here. So the key marker right here we got to look at is the eyes. It's the gills. I apologize. The gills. So here's the fish. Really can't see much. Kind of looks like he showed up late to the party. That's what it is. There's the salamander, but then the turtle, the chicken, and you see these folds, especially on these three right here. You don't see the folds. There are some structures, but not distinctive folds like he's trying to show here. Especially with the human. It seems more exaggerated on the human than any of the other organisms. Maybe not the turtle. You still see it on the fetus here. Okay? So, he was wrong, right? His drawings were wrong and misleading. And they're not gills. They're not gills. They never were gills. And we'll actually come back later. They're called pharyngeal arches, and we'll actually come back and talk to what they are. Okay. So, but there is a homology here with embryonic development, and it's not because of the evolutionary development retracing. It's because they're eukaryotic cells and how vertebrates develop in the womb, right? So, remember we just finished, right? Within 3 to 5 days, the cells begin to specialize. The stem cells become specialized cells. So that process starts when it becomes fertilized. The blastocyst is what we call it. It's just a group. Terrible drawings here. Ready? It's just a group, a bunch of little bitty cells, right? They're stem cells, all identical in the fact that they all do the same job. They're just growing stem cells, right? Just growing stem cells. Well, then what ends up happening later on is then they make this. Then they begin to make a sphere. They make a complete sphere, right? And so this is where the folding and the layers come from. So it's hollow in the middle and it's just a sphere. And it's going to collapse in on itself. It's going to implode, okay? And so what it's going to do, see if I can draw this, it's kind of like, all right, those layers start to fold in on themselves and it starts to build up on one side, okay? And then after a while, then you'll have the layers and this built up organism, okay? And so you'll actually have, because of the way it folded, you'll have 3 distinctive layers. You'll have this first layer, the red one, the ectoderm, the outside. Then you have the mesoderm, the middle, the inside, okay? Things like your organs and bone structures, nerves. Ectoderm is skin. Circulatory system would be mesoderm. The organs that are, they're all organs. Sorry guys, I said that wrong. And then you have the endoderm, that would be your digestive tract, okay? A little yellow. You can't see that yellow, or I can't see the yellow. Oh yeah, you can. Anyways, so you have the 3 distinctive layers, and it's just by the process of which the eukaryotic cells begins to specialize. It's not gills and all this other junk. Let's keep going. Let's talk about what Lyell actually. So not Lyell, I apologize. Haeckel. Haeckel was tried in court by Geneva University, and he lost because they were forgeries, and he openly admits to making forgeries. All right, so he's a freaking liar. All right. And this is his claims. I'll let you read the whole thing in detail. I can pause the video and read it. I'm going to read the parts that are important. He admits that they're forgeries. All right. He admits that he filled in and reconstructed the missing links by his hypothesis in comparative synthesis. I told you over and over in science that you have laws, theories, and hypotheses, and your hypotheses are developed by observations made in nature to explain the phenomenon. Okay, your hypotheses are not the facts; they're not the details. They're, you have a test, and it was actually established before Haeckel, but it was greater influence in the U.S. by Einstein when he came to the U.S. and proved that when we do research and you write a research problem, you're going to do an experiment. Your experiment, we should be trying to disprove your hypothesis. Okay? And so if you're going out to try to prove your hypothesis wrong and you can't, then that strengthens your hypothesis. Okay? But it has to be related to your hypothesis. It can't be unrelated. But anyways, it's not self-fulfilling. Okay? All right. And this is really what gets under my skin. All right? I should feel utterly condemned were it not that hundreds of the best observers, biologists, lie under the same charge. Makes me sick. I got me a BS degree, right? Bachelor's in Science. And if this is the moral standard of science, then 1, I don't want to be a part of it, and 2, how do we trust anything? Or trust them, not anything, but how do we trust them? And this is really what sets me upset about Haeckel, is his bold-faced lies and bad attitude. I'm showing you all this and going over all this is even in my college biology class that I took, my introduction to biology class in college. I remember my professor putting the exact drawings that I showed you all at first up on the board and talking about how, yeah, you have gills at one point. And it's bad science, and it's broken, bad, disproven, and yet they still teach it. We can pull off any of the biology textbooks off my shelf, and it'll teach the same thing when we're talking about evolution. It's rubbish, dude, and they still teach it today. Darwin claims that, hey, and it's important, and it's the best part of the research for his information. So what are they actually? Okay, so what they actually are pharyngeal clefts and arches. Okay, so the cleft is, yeah, we can see that with yellow, is the region right here. That would be considered the cleft. This region right here, the actual arches, or the arches. They go all the way across. They go all the way across the organism. They don't go only on the sides, like if you were a fish. Okay, behind the ears. These are and never were, okay, and never will be gills. All right. Okay. They end up making your distinctive facial features. So you had a funny looking face at one time. Okay, and they're actually important parts, and they call them pharyngeal because your pharynx, which is where your trachea and your esophagus meet together, and it's that little part that moves back and forth and allows you to eat and breathe. Okay, and on guys, it's your Adam's apple. Okay, and like I've already explained, there is homologies from embryonic development, but it goes as far as the fact that they all start out as stem cells that begin to specialize in the development of the way that eukaryotic vertebrates, okay, actually all vertebrates are eukaryotic, I'm sorry, that's redundant, all vertebrates begin to develop, so anything with a spine.